Good morning, students. Today we are going to see new chapter, combinatorics and mathematical induction. Chapter 4, very interesting chapter. Logically, you have to answer the questions. That's what, it's very simple. So we are going to see 8 problems today. Before getting into the problems directly, I'm going to teach you how to face the problem first of all. Right? Some basic things you must learn. Right? Arrangement of 3 persons. There are 3 persons, namely A, B and C. We are going to arrange them, seating arrangement. Okay, so 3 places, isn't it? So first I'm going to keep A in the first place, B and C in the second place. Secondly, the same way, A in the first place, interchanging B and C. I mean C, B. And third arrangement, keeping A in the second place, B and C in the first and third. And fourth arrangement, keeping A and interchanging B and C. Okay. Then naturally the last arrangement, keeping A at the third place, B and C. And sixth arrangement, interchanging B and C. So totally 6 ways we can arrange A, B and C. So since we have 3 persons, 6 arrangement. If you have 4 persons, 5 persons, you cannot write the combinations like this. It's difficult. So without writing these combinations, how you can find the answer? So that is what we are going to learn today. Before getting into it, I'll explain 2 important things. R. Whenever you see R, keep the word R in your mind. R means always plus and means always multiplication. R means plus and means multiplication. Okay, so that is very important thing. Right. Now, see 3 places, isn't it? A and B and C. This is the 3 places we are going to place them. So in the first place, I can keep any of the 3. So addition. How addition? I'll explain. A, R. Okay, A, R, B, R, C. It means A plus B plus C. A is a single person, B is a single person, C is a single person. So 1 plus 1 plus 1 is 3. Can you understand? A, R, B, R, C. So in the first place I can keep 3. Second place I can keep 2. How means? So in the place any of the person is placed. For example, A is placed here means remaining 2 persons. So B, R, C. So 1 plus 1 is 2. And thirdly, here suppose we have placed 3 means here remaining the last person C is placed. So 1. So A, R, B, R, C 3. B, R, C, so 2, C, it is 1. Right. Now, we need this first place and, keep the word in mind, and. You want this first place and the second place and the third place. So, and means multiplication. So, 3 into 2 into 1 is 6. 6 arrangements, we have got the answer 6. So, very simple. So, keep that in mind. R means plus and means multiplication. So now we'll get into the problem. The first sum, a person went to a restaurant for dinner. In a menu card, the person saw 10 Indian and 7 Chinese food items. In how many ways the person can select either an Indian or a Chinese food? Okay. So R, okay, keep that in mind, R. So he is going to eat either an Indian food or a Chinese food. So we can have 2 places first of all. R, so I have put plus. This or that. So suppose he is choosing an Indian food means he can eat any one of the Indian food, isn't it? First food or second food or third food or fourth food, such a way up to 10th food. So 1 plus 2 plus 3 till 10. Can you understand? 1 plus 1 plus 1 10 times. So first place can be filled with 10 ways. Similarly, Chinese food also we can place 7 times. Since this food or that food, 10 plus 7 is 17 ways. So number of ways the person can select either a Indian food or a Chinese food is 17. Okay, right. Now second subdivision, there are 3 types of toy cars and 2 types of train available in the shop. Find the number of ways a baby can buy a toy car and a train. Okay, the baby is going to buy 1 car and 1 train. So dash into dash. Okay, and I told it is multiplication. So toy car, any one of the 3. So 1 plus 1 plus 1, it is 3. Here it is Toy train 2, so 1 plus 1 is 2. Since he is going to buy this and that, one from this and one from that, 3 into 2 is equal to 6. So number of ways a baby can buy a toy car and a toy train is equal to 6. Second problem, how many ways 2-digit numbers can be formed using 1, 2, 3, 4, 5 without repetition of digits? Okay, 2-digit numbers. So 2-digit numbers, 2 places, isn't it? So totally there are 5 digits. 1, 2, 3, 4 and 5. 5 digits. Number of digits is equal to 5. Now 2 places, isn't it? 2-digit number, 2 places. So first place I can fill what? 5 digits, isn't it? Any one of the 5 digits. So it is 5 is placed. Without repetition, it means in this place any one of the number from the given 5 is placed. So 1 is left. So remaining 4 is there. So remaining 4 numbers. So that is placed here without repetition. So we want this place and that place. So 5 into 4 totally 20. So number of digits, number of 2-digit numbers can be formed is equal to 5 into 4, which is 20. Subdivision 4, 3 persons enter in a conference hall in which there are 10 seats. How many ways they can take their seats? Okay, they are going to choose the seats. Okay, but here you consider the seat is going to choose them. That's a funny way. So we have 3 persons, 1, 2, 3. So the first person can choose any one of the 10 seats, isn't it? So 10. Second person, so first person has chosen 1 seat, isn't it? So remaining 9 seats are available. That will be chosen by one of the seats from the 9 will be chosen by the second person. So 9 and remaining 8. So 10 into 9 into 8, so 720. So number of ways they can take their seats is equal to 720. Now sum number, subdivision number 5 from sum number 1. In how many ways 5 persons can be seated in a row? Okay, so 5 persons seated in a row means, you see here 1, 2, 3, 4, 5 seats. So first place can be occupied by any one of the 5 persons. So remaining 4 is there, then 3, then 2, then 1. So number of ways 5 persons can be seated in a row is 5 into 4 into 3 into 2 into 1, which is 120. Right? Now subdivision, sum number 2, subdivision 1. A mobile phone has passcode 6 distinct digit. What do you mean by distinct? Different. Distinct means different. So in what is the maximum number of attempts one can make to retrieve the password? Suppose the password is unknown. So how many ways he can try? How many maximum number of attempts he can put to find the password? So which is what asked in the question, right? So 6 distinct digits. So 6 places. Totally there are 10 digits, isn't it? Numbers 0 to 9, totally 10 digits. So we have 6 places. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5, 6 places is additionally is given. So first place can be 10, second place can be 9, third place can be 8, fourth place can be 7, and 6 and 5. 1, 2, 3, 4, 5, and 6. Okay, so it's wrongly given the 4. So totally the multiplication is multiplication value is 1, 5, 1, 2, 0, 0. So this is the way the maximum attempt can be done. Okay. Now sum number 2 in subdivision 2, 4 flags are there, different flags, okay, which can be arranged one below the other. 3 flags can be used for the combination to generate signal. So how many different signals can be generated, which is asked in the question. First flag below, second flag below, third flag. So since 4 flag, first place can be filled with 4, second place the remaining 3, and third place the remaining 2. So we need 4, 3 and 2. So 4 into 3 into 2, which is equal to 24 number. So number of different signals can be generated is 24. Sum number 3. 4 children are running in a race. In how many ways can the first 2 places can be filled? So 2 places, isn't it? First place, second place. So 4 children are fighting for the first place. So it is 4. So once it is first place is achieved or reached by 1 person, means remaining 3 is there. 3 are there that can be put into second place. So 4 into 3 it is 12. The number of ways can the first place be filled, that is 4 into 3, which is 12. Subdivision 2, in how many ways they can finish the race? How to finish the race? So first place, second place, third place and fourth place. So 4 different places. So this first place is occupied by any one of the 4, then remaining 3, remaining 2, remaining 1. We need all the 4. 4 into 3 into 2 into 1. So that is 24. Sum 4. Count the number of 3-digit numbers which can be formed from the digits 2, 4, 6, 8 if repetition of digits is allowed. 3-digit numbers, so 3 places. Totally we have how many digits? 4 digits. 1, 2, 3 and 4 digits. So totally 4 digits are there. 3 places. Since 3-digit number, 3 places are given. So first place can be occupied by 4. Since repetition of digits are allowed, you can use the same 4 in the second place and also in the third place. So 4 into 4 into 4 is 64. So number of ways 3-digit numbers can be formed without repetition is 64. Solution 2, the same question, repetition of digits is not allowed. You cannot repeat the numbers. So what we can do, the same 4 numbers, first place can be occupied by any one of the 4. Since one occupied the first place, I mean out of the 4, 2, 4, 6, 8, suppose this place is filled by number 2, remaining we have 4, 6, 8. So 3 numbers. So 3 can be used in this place. So from the 3, 1 is occupied here. So remaining 2 is there, that can be put. So repetition or non-repetition, very important. So keep that in mind. So here the same way number of 3 digits can be formed without repetition is 4 into 3 into 2, which is equal to 24. Sum 5. How many 3-digit numbers are there in, that means with 3 in the unit place, with repetition? So that is totally 10 numbers, isn't it? 0 to 9 are the digits, so totally 10 numbers. 3-digit numbers, so 1, 2, 3 places. So here you see the last unit place, always fill the condition first and then you start from the first. Okay, fill the condition first, then you start from the first. What is the condition here is 3 in the unit place. This is the unit place. So 3 is placed in the unit place. So only one person, the 3 can be put here. So this is 1. And coming to the first place can be, it is given that without repetition. So 3 is used here. So remaining 0 to 9, 3 is left, isn't it? So we have totally 9 digits are there, isn't it? Out of the 10, totally 9 digits are there. Okay. So 9, and when coming here in this place, you can also have 0, isn't it? Here you can leave the 0 and can you understand? In this place we have filled with 1, isn't it? So with repetition means you can use the same number of digits. So the first place again you can put 10, but the difficult is if you put 0 here, out of the digits 0 to 9, if I use 0 here, this is not a 3-digit number, it will be a 2-digit number. So 0 cannot be put in this particular place. So leaving 0, I have 9 digits. Can you understand? Right, now coming to the second place, I can put any numbers from 0 to 9. So totally 10 numbers. So 9 into 10 into 1, which is 90. So number of ways 3-digit numbers can be formed. Okay, keeping 3 in the unit place with repetition is 90. Now the same without repetition. So what will happen? Same 3 places, same way keeping 3 in the unit place. So 1. But here, so here 3 is placed here, isn't it? Here 3 is placed. So out of the 9, 3 is left. So remaining you have only 8 digits. So out of the 10, 3 is left, you have only 9 digits. Okay. See, 3 is left out. So 0 to 9, leaving 3, there are 9 digits. But first place you cannot place 0. So leaving 1 from the 9, it is 8. Now coming to the second place, in this place. So here one number is placed. So 10 minus 1 is 9. Here one number is placed. So 9 minus 1 is 8. So remaining 8 can be put in this place. So number of ways the 3-digit numbers formed with 3 in the unit place without repetition is 8 into 8 into 1, which is equal to 64. Sum number 6. How many numbers are there between 100 and 500 with digits 0 to 5? Repetition of digits allowed. So first way, totally there are 6 digits. 1, 2, 3, 4, 5, 6 digits are there. Now, numbers between 100 to 500. 100 to 500 means you cannot include 100 and 500. So 101 to 499. So 3-digit numbers, isn't it? So 3 places. Now see, first place can be occupied by the numbers 1 to 4. So let's see, 101 to 499 means you can have numbers from 1, 2, 3 and 4. You cannot use 0. If you use 0, it is a 2-digit number. If you use 5 means it goes beyond, that is above 500, it is asked between 500, so you cannot use 0 and 5. So leaving 0 and 5, totally we have 4 numbers, 1, 2, 3, 4, so 4 is placed. Second place, there is no condition, you can use any numbers, that is 0 to 5, so 6. Third place also there is no condition, because because repetition is allowed, so same 6. So totally number of numbers between 100 to 500, 100 and 500 with repetition is 4 into 6 into 6, which is 144. Subdivision 2, repetition of digits not allowed, same question. So here also we can have only 4 numbers in the first place, leaving 0 and 5. Second place, we have to keep one thing in mind, that means 1, 2, 3 and 4. Out of the 4 numbers, 1 number is placed here, so 1 is left out. So remaining we have how many numbers? Leaving 1 means we have totally 5 numbers. So 5 numbers can be put here. So now second number is placed, here 1 number and here 1 number. So out of the 6, 2 number is left, so remaining 4 numbers. So 4 into 5 into 4 is 80. So number of numbers between 100 and 50 without repetition is 80. Sum number 7. How many 3-digit odd numbers can be formed using digits 0, 1, 2, 3, 4, 5? Repetitions allowed. So odd numbers. So what are the odd numbers here? I have given in different color. Red color 1, 3 and 5 are the odd numbers. 3-digit numbers, so 3 places. Totally we have 6 digits. So 6 digits. 1, 2, 3, 4, 5, 6. So 3 digits, 3 places. And odd numbers, so first condition to be done first, I told. So last place is supposed to be an odd number, isn't it? So 3 odd numbers, so last number can be filled in 3 ways. Okay, last place is odd number, so last number can be filled with 3 ways. And first place, same thing, you cannot use 0, isn't it? Repetition allowed, so out of the 6 number, 0 cannot be taken, so remaining 4 you can put 4 here. Can you understand? Right, okay. Now in the second place, you have numbers like 0, 1, 2, 3 and 4, 5 can have 6 numbers. Okay, so repetition not allowed. So 4 can be put here. In the second place, I told that here we can place 4 numbers, leaving 0, remaining 4 is there, but remaining 3 is there. But in the second place, you can include 0, isn't it? So including 0, you can have 4. I'll say once again. Here odd number is placed, that is 1, 3 and 5. So 1 number is placed here. So remaining you have how many numbers there? 4 number can be put here, leaving 0. So now in this place you can include the 0. So remaining 3 including 0 again 4. So 4 into 4 into 3 is 48. Repetition of digits is allowed. So repetition of digits is allowed, the same concept. Again the last place is odd, can be filled. So first place can be filled in 5 ways. The reason is leaving 0, 1, 2, 3, 4, 5. So 5 can be put. Second place, all the numbers can be filled. So it is 6. So 5 into 6 into 3 is 90. Number of 3-digit numbers can be formed with repetition is 90. Last problem, count the numbers between 999 and 10,000 subject to the conditions that are no restrictions. Okay. So first of all, number of digits is 10. Between 999 and 10,000 means greater than 999 is 1000, less than 10,000 is 9,999. So you can see that it is a 4-digit number naturally. So 4-digit number, 4 places. Okay. So same condition, no restriction first of all given. So coming to the first place cannot be filled with 0. The reason is if you fill 0 in the first place, it will not be a 4-digit number, it will be a 3-digit number. So leaving 0, totally 9 digits. And remaining places you can take 0 to 9. So 10, here also 10, here also 10. So totally 9 into 10 into 10, which is 9,000. So number of numbers between 999 and 10,000 is equal to 9,000. No restriction. Secondly, no digits repeated. Okay. So here the same condition, 4 places, first can be filled in 9 ways. Digits cannot be repeated. The meaning is, so out of the number 0 to 9, other than 0, some number is placed here. So now what happened? Out of the 9 numbers, 1 is left out, so 8 numbers are remaining. 0 is now we cannot place here, but 0 here can be placed. I told that now remaining 8 numbers, 0 cannot be placed here, isn't it? So 8 plus, here you can place 0. So 8 plus the number 0, which is 1. So 8 plus 1 is 9. So 9 here. Now 1 is placed here. Out of the 9, 1 is left. So it is 8. Out of the 8, 1 is left. It is 7. So number of ways you can make this arrangement without repetition is 9 into 9 into 8 into 7, which is 4, 5, 3, 6. Now the last subdivision is at least one of the digits is repeated. So here you can easily do without this method. See, first one is no restrictions. That means all the digits. Second one, numbers, digits are repeated. Here at least one digit is repeated. So the meaning, sorry, no, here no digits is repeated. So previously, that means no restriction. Second one, no digits repeated. The third, they are asked at least one digit is repeated. At least one digit is repeated means at least 1 or 2 or 3 or 4, whatever it might be. So the answer is very simple. From the no condition, no restriction, if you subtract no digit is repeated, you can get at least one digit is repeated. So very simple. So that is what the answer. So what is the restriction? No restriction, which is 9,000. So 9,000 minus no digit repeated. Answer is 4536. So finally the answer is 4464. Okay. So very simple exercise. Take down in your fair note. No homework or no home assignment is given. We'll see the remaining problems in the next class. That's all. Thank you.